Hey guys, yeah, in today's video, let's focus on the single hypothesis where we will test whether the given statements or the claims that are given are to be accepted or rejected now. So the first thing that we have to understand is now, what is hypothesis? Hypothesis, we regard it as a claim about a population parameter. We regard it as a claim about a population parameter. It might be a claim about a certain mean, precisely means. Many times we regard them as mean, one of the parameters that we use, the sample mean. So in the hypothesis, we have the null hypothesis and the alternative hypothesis. The null hypothesis, we denote it by HO, and the alternative hypothesis, we denote it by H sub 1. H sub O is the null hypothesis, and the alternative hypothesis we denote it by H sub 1 or H sub A. From the null hypothesis, this one are the numerical that are to be tested, and always is about population parameter. The null hypothesis always is about population parameter. It is not about the sample statistic. So let's go into this example and do one of the examples. In this example, we are given the grocery store believes that grocery shoppers in Limpopo spend on average of 180 during each visit a supermarket. To test the benefit, to test the belief, the market researchers are to conduct a survey among a random sample of 250 grocery shoppers at the supermarket in Limpopo. Don't forget that here we test a claim. That's why here we hear about the market researchers. They that are about to conduct whether is it true that that grocery shoppers in Limpopo spend on average of 108. So the survey found that the average value of the grocery purchase was 195,7. Assume that the population of grocery purchase was normally distributed and that the standard deviation of the value of the grocery purchase is 60,5. Here comes the first thing that we must do. Identify the null hypothesis and the alternative hypothesis. Secondly, they say, can the grocery store conclude that grocery shoppers spend 108 on each visit to a supermarket? Test statistically at the 5% level of significance that the mean value of the grocery purchase is 190. And now comes the test. Now what do we test? Which parameter? Don't forget that we said the null hypothesis always test the parameters, population parameters, not statistical parameter. Not sample statistic. The null hypothesis always tests the population parameters. That's why here one of the parameters that we must test is the mean value of the grocery purchase is in Limpopo is 108. So now they say let's identify the null hypothesis and the alternative hypothesis. Here is our null hypothesis. Our null hypothesis is this mu. This mu is our null hypothesis, is equals to 108. From our statement, we are given that the average that is spent in Limpopo during each visit is 108. That's why here is 108. What is our alternative? Our alternative is always the opposite of the null hypothesis. In the null hypothesis, we test the null hypothesis is always about the parameters of the population, not the statistics sample. That means our alternative will be the sample statistics, not the population parameters. That's why here our mu is not equals to 108 in the alternative hypothesis. Now we are given, let's go to the following statement where they say test statistically at the 5% level of significance that the mean value for the grocery purchase is in Limpopo is 108. What we have to do, we have to use this formula where we say this Z, we regard it as the statistical evidence. Yeah, we use it to check the statistical evidence is equals to sample mean minus mu divided by the standard deviation. Then we divide the standard deviation by the square root of n. From there, we are given that our sample is 250. Here it is some random sample of 250. And our sample mean, we are given that is 195.7. The survey found that the average value of grocery purchase was 195.7. Then we are given that our standard deviation is 60.5, while we are given that our level of significance is 0.05. And guys, yeah, highlight what I'm about to say here. If you are given a statement and they don't give you the level of significance, that's not by default. 0.05 is our alpha level of significance. Now, some of the statement they will not test statistically at the 5%. If they didn't give you any percentage at which percent to test, then you know by default automatically our alpha is 0.05, which comes from 5%. Now we added the value in this formula. From there, our answer we got 4.10, 4.10. From there, this is our statistical value. Now we have to look for our z value before we conclude or indeed this statement is true or not. How do we get our z value? Our z value, we get it the same way we are used in normal distributions, in sampling distributions, in confidence intervals. Our alpha was 0.05. Here is 0.05, 0.05. We divide it by 2. You may ask yourself why we divide it by 2. In null hypothesis testing, when our average is equals to 100 and something, when for the figure that is equals to, we are going to divide it by 2. We divide by 2 this side and this side. But if our average was greater than or less than, we are going to focus on one side. But since they say is equals to, then we know we focus on both sides. That's why our alpha, we divided it by 2. From there, when we divided by 2, we shaded this area. We shaded this area. Then for our critical value was 1.96. 1.96. I'm sure you know how to get the critical value of the level of, of the level of the 5%. We know is 1.96. From there, since our critical value is 1.96 and our statistical value is 4.10. Now, can we conclude, or this statement is true, that the average is 108? Can we conclude yes or no? Then, how do we conclude? Take care of this, emphasize this. If your Z statistical is greater than Z critical, then you have to conclude, you have a strong evidence that the mean is not your value. Yeah, before we continue, this area that is not shaded, that's where there is acceptance region. We accept everything here. When our values lies here, then we accept it. But if our value is in the shaded part, that means we are going to reject it. That hypothesis, we are going to reject it. From the since our Z statistic was 1,0 and is greater than 1,96, our Z critical, then there is a strong statistical evidence that the mean grocery value is not 175, because our researchers, they said they are purchased the survey grocery price. Let's go up from there 105, from there 105, 105, 105. Okay, yeah. Now I see it here. We're supposed to, this mistake, we're supposed to say there is a strong statistical evidence that the mean grocery value is not 180, is not 108, not 175. We made a mistake here. It was supposed to be 108. Then we conclude. Why we conclude? Because our Z statistical is greater than the critical value. But if the critical value was greater than the Z statistical, that means no, the evidence that we have is not strong enough to oppose the given statement. Thank you very much. So I think we'll create another video where we'll explain the hypothesis that we will be given maybe our average is greater than or less than. Thank you very much, guys. Thank you very much. Feel free to comment or to ask a question so that we can elaborate it together. We can elaborate it further. Thank you. Thank you. Thank you.